Oh, hi, welcome back to the channel. So this is problem 7.5, thickness of soil beneath footings to give load factor of 3. At a certain site, the subsoil consists of a thick layer of soft clay, Cu equals 20 kilonewton per meter squared, phi U equals 0, which is overlain by a stiffer clay, Cu equals 87.5 kilonewton per meter squared, phi U equals 0 of variable thickness. The ground surface is horizontal and the water table is at considerable depth. So the ground surface is horizontal and the water table is at considerable depth. It is proposed to install widely spaced footings 1.5 meters square at a depth of 1 meter below ground level in the upper clay material. Estimate the net working load on the footing using a factor of 3. If the footings are fully loaded at this pressure, estimate the thickness of stiff clay required below them in order to ensure that the load factor against shear failure in the soft clay is at least 3. Ignore settlement effects and assume a load dispersal at 30 degrees to the vertical. Usually I would say 45, so I don't know why I got 30. Take NC equals 7.5 on the lower clay and assume Terzaghi's bearing capacity equations apply. Okay, so that's the question. It says ICE though, so does that mean Institution of Civil Engineers? Solution. Terzaghi's equation for a shallow square footing on clay soil, so that's cohesive soil, with phi u equals 0, so that means the angle of shearing resistance is 0. So it fails like a line on the horizontal. So the equation is, QNF equals 1.3 C NC. So it's cohesion only. There's no help from the other factors. So NC equals 5.7. For upper clay, QNF equals 1.3 times 87.5 times 5.7. The 87, that's the high, that's the higher clay because it says it's overlaid by a stiffer clay. So the top clay is the NC equals 87.5. QNF equals 1.3 C NC, and NC is from the tables. NC is from the previous table. For upper clay, QNF equals 1.3 times 87.5 times 5.7 equals 648 kilonewton per meter squared, so that's pretty high. Using a load factor, doesn't it mean using a safety load factor? Using a safety factor for load of 3, the net allowable unit working load is 648 divided by 3, it was 216 kilonewton per meter squared. Net working load total on footing 1.5 meter square is 216 times 1.5 squared equals 486 kilonewtons. So that's quite high. Because when I do foundation design, we always just say it's got to have a minimum bearing of 100. So not that I've actually calculated any foundation loads recently, but the net working load on the footing is 1.5 meters square. Assuming this is dispersed at 30 degrees at depth set below the footing, see figure 7.5, the load will be spread over an area of 1.5 plus 2z divided by 3 root of 3 squared meters. An area of, right. So the load will be spread. So they're saying it's going to be spread over a shape that is similar to a pyramid, similar but without at the base. So it's going to the length of the side of the pyramid at the base will be 1.5 plus oh yeah, 2z divided by the root of 3. So how do they work that out? Because it's 30 degrees. Oh, so z, sine, no, it's tan 30 equals the distance z over square root of 3. 1.5, 1.5 z divided by, tan of 30 equals that distance x, or let's say it's called y. Tan 30 equals y over z. Tan 30 equals y divided by z. So y must equal z divided by tan 30. So tan 30 must be the square root of 3. I don't know, it doesn't tell you that, but it must be. Tan 30 is equal to the square root of 3. So then y equals z divided by root of 3, yeah. That's how they get it. Oh yeah, so here you got, so it's plus, 2 times z divided by root 3, because it's on both sides, isn't it, 30 degrees. And then that distance is squared to give you the area. So the pressure on top of the lower clay, is that the maximum allowable pressure on top of the lower clay stratum equals 2. Shouldn't that be, oh, hold on. No, wait, 486. Where'd they get? Pressure on top, yeah. Shouldn't it be? Oh, right. Pressure on top of the lower clay stratum equals 486. Oh, yeah, because it's... Oh, no, hold on, sorry. What was I talking about? These three. Oh, yeah. It says Z. Oh, because Z is unknown. Is 486 divided by 1.5 plus 2z divided by root of 3. That's all squared. Allowable pressure equals QF divided by 3. 7.5 times 20 divided by 3. QF. Where'd they get 7.5 times 20 there? Oh, sorry, there's NC. NC equals 7.5 on the lower clay. NC equals 7.5 on the lower clay. And times 20. Oh, because that's 20, 20 kilonewtons per meter squared times 7.5 on the lower section of clay. The allowable NC on, they've missed out a step here, haven't they? Pressure on top of the lower clay is that. The allowable pressure is QF divided by the safety factor of 3. NC for the lower clay is 7.5, and the CU for the lower clay is 20. So that means it's 7.5 times 20 divided by 3 equals 50 kilonewton per meter squared. Equating these two pressures equals, oh right, 50 equals 480 divided by 1.5. Oh, so the pressure on top of the lower clay stratum equals 400. Oh, so it's basically depending on the depth, isn't it? Equating these two pressures equals 50 equals 480 divided by 1.5 plus 2z divided by the root of 3 squared. So that means 112.5 plus 173z plus, oh, that's a quadratic equation, isn't it? That's a quadratic equation. I remember that from A-level maths. Oh yeah, z squared plus, right. So that is 112.5 plus 173z plus 66.7 z squared equals 480. So what are they saying? Divide, oh yeah, minus 5.3. They've missed out a couple of steps here, haven't they? Oh, so you gotta, if you take away 480, oh yeah, moving 112 to the other side. Oh yeah, sorry. So you move, the 480 comes to the left, and then that gives you what, 300 and something, 360 odd, doesn't it? 67 odd, 367.5. And then if you divide everything by 66.7, divide all of the terms by 66.7, then so z2 then is equal 1, 2, oh yeah, and 3. And then you've got to solve a quadratic equation. Z squared plus 2 plus z squared plus 2.6z minus 5.43 equals 0. That means that z is 1.35 meters. That's, oh, so that gives you, oh yeah, right. It's an interesting example. I don't think it's very well set out on this thing, do you? It's not very well set up, and it doesn't really, some of the workings are missing as well. And it should say at the final level of the, go back over the question again just to make sure. If the fittings are fully loaded at this pressure, estimate the thickness of the stiff clay required below them in order to ensure that the load factor is safe against shear failure in the soft clay is at least 3. So it's got to be 1.35 meters. It's got to be 1. So the stiff clay has to be at least 1 point. That's a minimum. The stiff clay has to be a minimum of 1.35 meters. Whoa. Figure 7.5. Okay then, so at least we know that roughly. It's not the best examples to be honest, but at least we've got an idea. Give you an idea of clay. Okay then, hopefully if there's any questions, please put them in the chat. Please like the video, please subscribe to the channel so I can keep making videos and I can keep going through these things. Thanks. Thanks a lot. Hope you found it useful.